Let's see if I'm on now. Yes, I'm on. Okay. Yeah, I'm sorry about earlier there. Yeah, a little bit of explanation. Don't mind the mess here. Pretty well in the middle of the night here. I was going to record this, but my phone is dead. It was on the spot. I decided to set up my Variac in the way that I showed you, my solid state moray generator. So I tuned it just like in the diagram, and it seems to be working really well. There's pretty big current accumulations, and so I decided to put the charger on there, and I just wanted to monitor with my phone, but it's dead, and it's on the spot, so I want to document this here. So it seems to be doing interesting things, um, getting peaks of 1.1 amps, and the battery is flickering from 12.3 to 12.4 and sometimes 12.5. There's 0.7. Sometimes it goes 1.1. And I find it pretty fascinating because the inverter is running really, really cold, no fan. I've got the voltmeter down here. It's hard to get a lock on it because it keeps fluctuating with the input charge, but it seems to be doing 12.33 and flickering all the way up to 12.37. So I was just observing to see how long it was going to do that before it starts to drop, like if it will, which I would assume, to 12.2. But it's very interesting because the battery, I could actually hear it boiling, clicking from here. And it's never done that before. So, and all the variance, really quick variance is different. So now I'm looking at the meter 12.35 down here on the voltmeter. 12.3, 12.5. See what I mean? It really jumps. Then it goes down and then it jumps and then it goes down and then it jumps. 0.9 amps now. 12.3, 12.5, 12.3, 12.4. So you can see how the charger tries to work with it, right? But this is very interesting. But again, don't mind the mess. I was all in the middle of something. I got all the wires everywhere. All I'm running right now is the inverter going in line with pretty well like in the diagram of my last. It's just I don't have the 5 light bulbs in line. So, but apart from that, I'm using the charger instead. I was able to tune. That was an interesting experience with the light bulb. And I'm just monitoring right now, but again, I've got so much stuff on the go here. Um, we're live, good audio. Yeah, sorry about the audio earlier there. So I'm just monitoring the battery here. Let's see what it's doing if it's still clicking. That's going click, click, click. I can hear it like when you're charging the boiling. I'm just curious because how it's fluctuating and the fluctuations are tendency up, not downwards. 12.5, 12.3, then it jumps. So apart from recycling, there's something really funky going on, and this is relatively basic into what I had in the. So I could just imagine the proper way of doing this, what it would do, you know. This is just crude testing, you know, with what I got to see if there are at least any effects leading in the right direction, you know. And this might be an effect in the right direction, actually. And I wanted to record this, but my phone is completely out. And I want to wait, you know, because it's happening now. So at least with the live, I'll have the archive and I'll have the result of this. Again, I don't always like live if something goes wrong or something, but I don't know how long I'm going to be at this here. So 0.8, 0.4 for them. It fluctuates its charge. 12.3, 12.4, 12.3. See, it's fighting it quite a bit. And on my meter here, let's see, we're fluctuating at 12.33, 12 point, fluctuates on 12.34, 12.34, 12 point. So you see with 12.45 there for a moment. So this is really unusual. Just the odd thing is with the charger going back into the battery, it keeps, I guess it's a pulse kind of charging, and it always varies the voltage on my meter. I have to quicker than I can see it. So let's see what it's doing. 12.4, 12.3, 12.4, 12.4. So running it properly, the right capacitances and the right, I just tuned what I had to work with. The right load on there would be nice too. Perfect LCR, reactive, 12.4, 12.3, 12.4. That's pretty interesting. 1 amp there, it just gave it a 1 amp burst. So let's see, I have my temperature sensor. Where did I put that? Now I'm going to get that. Check things out with the temperature. Okay, battery. 69.8. Check out the inverter. Inverter 75.2. Let's see if those capacitors are getting hot. Capacitor 75.9. Okay. Oops. 75.9. 12.33 here. Now it fluctuates a lot. 12.33. So we're getting here 12.3, pretty close. 12.4, 12.4. So you see, it's non-typical charging, you know. It doesn't do down to 12.2, then back up to 12.4, and 12.4 now. And I've seen bursts of up to 1.1 amps. I'm hearing it again. I can hear it boil from here. Click, 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 click. At first, I thought it was water leaking from my window, and then I was under the table until I realized it was. That's what it sounds like. It sounds like little drops of water. Wow, she's really going. I could hear it boiling. I'm seeing 12.37 on my meter now. 12.37 on my meter. Huh. And I haven't even grounded it yet. I'm not too sure where I should ground it. There's several spots, you know. I'm not there yet. Let's see what people are saying here. Yeah, basically, I just did what I did in my circuit diagram, and I followed that, and I'm just fine tuning. And it was like a spot. I could hear it. I was fine tuning. There was nothing. I tuned with the light bulb first, and then all of a sudden I got this whoa, 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 and then I started fine tuning, and it started going faster. Whoa, and then all of a sudden the light just got really bright. And when I moved it a little bit more, it went back off. So then I went back the other way and I started doing that. Whoa, 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 whoa. Then I disconnected the light and I put the but it's all in the loop, you know. So yeah. So, but you got to mess around with your. I was about for an hour and a half with the help of Chat GPT calculators with all my series, and you know, my variac is this much. I have this much capacitance here. Trying to find the right capacitors values for 60 hertz, you know, with what I had around the house. So it's like, okay, well, take 222 UFs, and then you know, I got it. But anyways, I finally got a combination where I had to be, which was in range of the variac. But that's essentially, you know, the annoyance with it. You have to find that resonant point. So I just wanted to see for myself, you know, quickly if the I knew it was going to work, but it's just you know how intense with, you know, not the big one, just with what you got. But if I had my choice, I would go exactly like I put in the schematic, 70.4 UF and 70.4 UH. And like ChatGPT says, with the vacuum capacitor in parallel for the fine tuning, if that's necessary, that would bring the greatest with everything I tried at 60 hertz, anyways. But you see, I'm using what I got. It's easy to get 60 hertz variac, 60 hertz, you know, everything. It's industry standard at 60 hertz. It may not be as efficient, a lot oversized, but easy to work with. So here I am talking and talking, 12.3. See what else we're going to get here. What am I getting on my meter? 12. Flickers so much. 12.33. 12.3 on here. 12.4, 12.4, 12.3. So I've been doing this flickering thing. So yeah, I mean, this is like very bad and relative to what I had in the circuit diagram. It's just stitched together literally, but it looks very promising. It really does. My inverter's running super cold, you know. Usually when I start taking a couple watts out of this thing, there's a sensor, you know, the fan kicks in. So that's another indicator that I know that I'm putting out peanuts from what I'm getting back in. If this is right and I'm indeed putting out 1.1 amps, which, you know, if I'm hearing the battery boiling, you know, everything seems to be good, solid indicators, you know. I look for everything. So let's see what everyone is saying here. Yeah, this is like 1:30 in the morning here. I wasn't expecting any of this. I just tried something before bed and then it looks like it's successful. So I can't even record this like I wanted to. My cell phone's dead right now and it's charging and it's happening. And I said, well, I guess I'll just go live. So Terrence Howard, I think I may have. There's so much out there. There's a few good people on Twitter as well. Well, whatever you want to call it, X. So yeah, hello everyone. I'm sorry I've been like I said, I'm trying to mostly keep an archive of this experiment for future references. Everything's a mess here. I realize I've been at it all night and I'm working on something else here. Isn't even plugged in yet. This is gonna be my, oh my god, an oversight. It's so heavy. I don't know if you see that. It was my coax and I got my secondary loop all around there. Probably a couple thousand turns. Telephone cable wrapped around, say 10 turns of LMR 400 coax cable. So I got a plan for this for another project, which I'll get into, I guess in a few weeks from now once I understand what I'm trying to do here. But this is very heavy. It must be close to 50 pounds. So 12.3, 0.9 amp. Twelve point three, am I still hearing it? Strange. It's like the boiling comes and goes. Like right now, I'm not hearing it, and when it starts there, you could hear it from like several feet away, and then it calms down for a bit. I'm not hearing anything now. I'm not hearing it boiling. That's weird. It was clicking away. I could hear like water dropping on my window. No, battery's not boiling right now, whatever that means. So let's see. Power still at 12.33, flickering a lot here. 12.34. Am I getting out of the 12.3, 12.4? It's still flickering on the charger. Sorry if my volume is low. I'm just a little intrigued that the cycles of, for a few minutes it boils, for a few minutes it quiets down. For a few minutes it boils, and I don't touch anything. I'm just here taking the readings, and that's a little odd. So 12.33 here. Whenever I get a lock, it just flickers so much. I have a hard time. It's This one here is more stable when I get the reading. But it's still going 12 point. It wants to go. It keeps fighting it. So I was going to call it quit at 12.2 and just basically assess from there, figure out the efficiencies and where to take it from there. I don't know if I'm going to be up all night here. $12.3, 12.4. Yeah, it's oscillating like that. Hmm. So here's that 12.4. Let's see, monitor my temperature here. Inverter 73.8. Battery is 68. Let's check those capacitors. I'm sometimes worried about the capacitors. 71.8, does that make sense? Oh, 74. 76. Okay, so they're not bad, but the capacitors are a little warmer than room temperature. So the capacitors are slightly warm up. So I'm losing a little bit in heat. So that would probably be, I don't know, the coil is not rated high enough for the circulation of energy right now. I'll have to hash that out later. It's too late. Let's see what people are saying. Hmm. Yeah. Oops. I am hearing. I hear you don't hear this, but I hear it buzzing strongly through the. I hear the capacitor and coil working, believe it or not. 12.3. 12.2, so I can go to bed. I wasn't expecting doing this or starting an experiment late. This was just like an idea. 0.9 amp. Does the boiling work? For a while, I was actually worried because, like I said, I thought it was actually rain falling or drops coming through my window, and it was coming out of the battery. So that was kind of odd. So there it is now, 1 amp, 12.4. It's, I don't know what it's doing. I don't know what it's doing. I have an idea what it's doing, but I really doubt I've got over unity with these parameters. Very lossy, just slapped together, if you know what I'm saying. But I'm looking for the efficiency factor, which seems to be, at least for now, pretty good, 12.3. If I'm bursting, continue very, like on average, 1.1 amp, And we've been talking all this time. I mean, my battery should start wearing out, especially that it's pretty well dead to begin with. So very interesting behavior. So this is definitely something I want to document. Twelve point three, then it'll probably jump to 12.4 again. But yeah, the reason I got all excited is because I was hearing it in the battery there, and it was fluctuating a lot. 'Cause, I could keep it, like one time I had it all night, stayed at the same number. This thing is, there's a lot of peaking going on. 12.4 again. I want to go to bed. 12.2, and let's call it a night and say it was successful. Hmm. What time is it? Uh, 1:30. I was going to say, well, at least it's not that late. It just feels like it's 4 in the morning. But with that said, I have to go for a washroom break. The wonders of life. So I shall be right back. I'm just going to read real quick. I'll be right back. It's the same before I leave. And be good, Wolf. Don't chew on the wires. Thank you. Alrighty. Back in business. So yeah, people are trying to figure out the current and wattage. I keep things simple because everyone online argues, and when you start playing with AC and DC and pulse and amps a second and the true RMS, and they start arguing, and everyone gets it wrong. I keep it very, very simple, folks. I measure the current at the inverter's 12-volt input, so it's 12 volt, whatever the meter says, so 40 mA, 12 volts. And I simply measure what the charger is putting back into the battery, 12 volts, 1.1 amp. Easy as that. So of course, later on, I could break it all down through the various stages in the system. But what interests me the most is input, output, final, converted, transduced, whatever, what I'm putting in and what I'm getting out. So this way here, you can't really argue with, and I'm seeing it when I put the meter in line with the inverter and I see something like 42 MAs. And here I'm getting 1.1 amp back at relatively the same voltage. So that's what I'm finding interesting. But of course, with batteries, as I've explained before, trying to self-loop is difficult because you sort of got like a conflicting flow of current there. It's always very difficult. So it eats up most of your gains. You know what I'm trying to say? It's a lot smarter to charge several other batteries or more than, it's separate from the run battery, as demonstrated in my circuit diagram. But I'm just doing this, what's the saying, for shits and giggles, to see the efficiency. It's a very quick way of knowing if the system really is efficient, because if the battery could even stay at the same level, you've got more going in because the battery is just eating the majority of your gains, right? So that's what I'm getting at. So that's why I'm all excited when I'm seeing 1.1 amp coming back, when I know, especially through the reactive mathematics, I can't suck out more than 40 milliamps or so. And when I validate in the meter, it's like dead on, right? So that's what excites me a lot. But it's a shame that when we have this notion, right, everybody wants to see the self-loop setup, but you lose so much when you self-loop. It's almost not practical to do that. You may as well have one battery and then charge 10 dedicated, 10 charge batteries, one run battery. Keep the run completely isolated from the charge at all times, so you don't get that conflicting current flow that they'll just eat up whatever it is they're trying to put back in. Just generally speaking, It's not impossible. It's just, with the right timing, especially when you're pulsing the in and the out, you'll get moments where the battery's in the receive state. But, you'll be fighting against yourself more, unfortunately. So 12.3. Kind of still seems to be doing its thing. I'm still reading the same jumps on the voltmeter down here. It jumps around from 12.3 to 12.4. Once in a while, 12.5. And I'm monitoring. So far, it hasn't. When it goes down, it doesn't hit anywhere near the 12.2. I'm just waiting for that to call it a night. Waiting on that to call it a night. Or whenever I get tired, if I can't keep this up no more. At least I'll have it documented. Let's go see what everyone is saying here. Speaker, yeah, well, actually, what I've done a few times with the Bedini is I just placed the speaker on top of the coil disconnected, and it just vibrates from the magnet. And when I hear the strongest tone, I've done something like that before. Or another thing I do is I place a compass on top of the coil and I see, for the maximum swing. I've done that. And the compass it'll be almost like a motor, go and it vibrates. Yeah, that's my dog. She owns the whole sofa. She wants to go to bed. She's wondering, why am I out here yapping? Yeah. And she makes her nests and everything. I can't stop her. She'll pull clothes out of the laundry and I gave up on trying to keep it neat. The sofa anyways, because she goes and gets clothes and ah well. The life of owning a wolf, I guess. So let's see, what am I getting here? 12.33. My good lord. How long have we been at it here? 34 minutes, not bad. About an hour total for me. That's what I like doing too, because people sometimes when I do a 1 minute video, oh, he's doing something, and then he cut the video, charged the battery, and then stitched it back. Things like people come up with all kinds of. There it is, 12.4. Still, 0.91 amp just now again. The charger seems to adjust as it. I think it might be confusing the charger a little bit because then it thinks the battery is charging, and then I see it gives it a zero point 0.4 of an amp, and then it goes back down to 12.3, and then poof, 1 point, there it is, see 1 amp. Then it gives it a. But again, this is very crude. I'm probably losing a lot with this. If I were to have like a direct cap dump it, that would probably work. I'm still waiting. I bought like 50 SCRs, can you believe it? From China. Still waiting for that to come in. That'll probably be a lot better. But again, just using what I got, experimenting. And there it is, 12.4. It's trying to. We're back up to 1 amp. So can you imagine during this time, instead of doing this, you have another motor running that's a generator or something. There's a lot of options, different configurations. I don't like mechanical myself, but some people are into that, you know. It's pretty good. It's pretty good. It's making me feel pretty good that this is doing what I think it should do. But I've looked it up and I could actually find the values I need. There's actually real motor capacitors that have that 70.4 UH and inducers too. So that'll be interesting to experiment with the actual values I want and not with like what I had here. But needless to say, there it is, 12.4 again. It's like the charger detects when it goes down to 12.3 and then boom, it bursts it back up to 12.4. But I think that's what it is. It gets confused and then it starts to ease off on the current and then it realizes, oh, the battery's dropping, gotta give it another go. And the battery peaks. It's weird. It's all fun though. It really is. I think, anyways. 12.4 again. Time is it? Almost 2 o'clock. Am I ever gonna go to bed? Ugh. Can I explain what's happening? It's very difficult here. Basically, testing a crude version of my last circuit diagram, modern day Moray generator. It seems pretty promising so far, anyways. Oh, I just saw a 12.37 there hit on my meter. Let's see what it's doing. It's sustaining it pretty good. But again, I'm wasting so much by doing this self loop thing. If it's 1.1 amp, isn't that like at 12 volt, isn't that close to 14, 15 watts? I mean, it doesn't take 15 watts to maintain a battery that's only putting out but that's the conflicting of current, you know what I mean? you're eating all that up just to notice a slight a gain or a even. But this is not how I'm going to run it. I got to find myself 24-volt batteries and 5 of them somehow and put that in the actual loop, and then have another separate battery, which is going to be the run battery. It's just so much smarter to keep the run and the charge completely separate, because this way here you can match your battery as part of the impedance in the loop and get the perfect reactance stage, and use the light bulb on the one side as crude current rectification so that the battery charges with the positive cycle, and then the lamp takes the load for the negative cycle. So you keep your magnetics, you don't screw around with the loop. There it is, 12.4. It's just fighting it nonstop, which is really interesting. Needless to say, right? I mean, this is totally atypical of charging a battery session. What kind of dog? Papillon. You don't see it because she's all black, but she's got all of the poofy ears. Very spoiled. Treats and all that. But the only thing I get a bit annoyed with is the mess. She takes all the clothes and makes a pile and digs in there, and oh well. And I'm telling you, she'll like, she looks little, but she knows how to like stand on her feet, and she gets like to halfway up my height, and she'll go right in like the laundry basket and pull out pants, and it's like, what are you doing with that? You know? Uh Motor for using the load. Yeah, that's what I was just talking about. That if I don't have anything mechanical, but as long as the resistance is fairly low and the coil values can match for your resonance, it should make a difference, really. Some people have already thought of that. They're like, you know what? I want to replace the light bulbs with generators. Well, the only issue with that, you got to make sure that, in my design, I use the light bulbs as a crude rectifier. So they absorb the negative just by the placement of the way, the current flows. So I'm not too sure how it would react with motors, but anything with fine tuning should work to some extent. I wish I had all the parts and the resources to do all this, but gotta use what you got. So 12.3, 0.9 on the NAM, so probably gonna jump again there. 12.3. 1 amp, it just gave it a 1 amp burst. 12.4 again. See that every time it gives it like a high current burst, it wants to top off. Let's take a look at my temperatures here. Where did I put my gun? Over here. Inverter warmed up a little bit, 74.5. Battery is at 68.7. It's pretty well at what it's in here. Capacitors, 77.7 with the capacitors. So I'm not 100%. I'm close though, because any heat is an indication of loss, right? Could be worse, obviously. So pretty good, you know. It's not even it's going to burn you. It's just slightly above. 12.4. My goodness. 12.4. Yeah, unfortunately, I used to have three, four 12-volt batteries even, and when I moved here, I had to make room and I had to put a bunch of them, away. And I kept this one here, which was the best one, the one that I worked the most with. And yeah, so right now I don't even have, because that's what I would like to do is I would like to take one battery and put two in the loop. I just don't have those parts right now. So I'm just screwing around with this configuration to see what it's going to do. But I have to keep reminding people. 12.4, 12.4. Come on, 12.2 so I can go to bed. I get it. It's working. It's efficient. My idea is right on. Yeah, I guess if I were going to record this, I would have ran out of juice one way or another, given it's working like this. That's the thing. I got the other meter down here. It responds a lot faster than this one here. And I'm not seeing it drop anywhere below 12.3. And the meter catches faster up peaks. I'm seeing up to sometimes 12.45, almost 12 point, yeah, almost 12.5. But this one here isn't catching it. 12.4. Ugh, I shouldn't be complaining, really. It's just the timing is totally wrong. I was heading to bed at around 12 o'clock. Then I turned this on and I had, I was fine. I didn't think I'd get a resonant point with what I had. And I found it. And then I said, I got to try this. Four 12.3. We're going to come back. 0.9 M. It probably will. So I still got to figure out what to put ground on here. Maybe on one of the Variacs. This ground can't make it any worse. 12.4. Now it's really flickering. It's going 12.3, 12.4, 12.3, 12.4, 12. It wants to go 12.4 more than 12.3. 12.4. It's fun to watch, isn't it? I'm sorry if you guys can't see the, trying to repeat it as much as I can here. It must be a small writing from there. So the charger varies. It gives half an amp to 1.1 amp burst, it seems. And depending on the burst, that seems to excite the battery pretty good. Zero 0.9 amp. That was a pretty big burst. 12.3. I'll probably see the 12.4 again. $12.4. Oh, I'm actually starting to get a little dizzy here. Now, Fufi, you want to go to Dodo's, huh? Yeah, you're wondering, what is he doing? I want to go Dodo's. I'm hearing all this humming and clicking, and oh my goodness. Don't worry, we'll go soon. I'm just going to wrap this up. Just a little more, okay? This is important. Sorry, Wolfie. Oh, I know, I know. No, 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 no. I want to go pee pee. The pad's right here. Go pee pee. No? What's the matter? I don't want you hanging around here, Wolfie, because there's a lot of wires. Come on. You are all asleep. You're usually asleep. This is why I'm doing this. Because you're asleep, away from everything. You know? You want to go to the one spot. You've got a whole apartment and you want to go to the one spot. You know those wires are live. Like she knows that. It's good. Thank you. Go to bed, fat ass. Okay, thank you, sweetie. Yeah, sorry about that. The wonders of being live, everyone. No, I haven't. The stuff from Rick, I've never really. I tried talking to him a few times, and it never hit right. So he was actually rude to me. Basically insinuated I didn't know what I was talking about when I recommended a modification for one of his Bedini devices. And he got all offended, actually. Are we here to talk about electrostatics or free energy? Buddy, I was giving you a hint. Run an electrostatic disk on your Bedini motor for an additional input and cap dump. He took that all the wrong way. How dare I? He knew everything. There's nothing there. Okay, I just don't waste my time with people like that, you know? So they think, not that saying that he doesn't know anything. I'm sure there's some stuff he knows that's good. He's been with Bedini after all. But, when people tell me that'll never work, that's usually when I turn around and do my own thing and realize it is going to work. But that's what I realize. All these people, they're all in their own little I don't know how to explain it, closed little groups. But unfortunately, Rick went on his own because he started arguing with everyone else, you know. So he's not with the Dollard people and Eric and all that. And then too, there's another group, you know, their shit don't stink, you know. Again, sorry for the language, it's really late, but that's what I notice in this field, you know. Everybody quote unquote has it, but no one's actually doing anything. It's mind boggling. And when you ask them something that's a little bit out of their, you know, what they're into, they ignore you or they're rude. So again, screw all that. I do my own thing. I present what I think is valuable and I take it from there. So we are at what now? $12.3. Give them a flicker. Sometimes you just gotta wait on the meter. It'll tell me, you know, it's 60%, it's whatever, and then it takes a few seconds for it to flip. 12.4, there it is. So yeah, pretty good for what it is. Um, I was gonna stick around until it went down to 12.2, but it's still peaking in the, you know, it's not dropping. Just because I also don't want to run my battery at 12.2 because it's not smart to do that. I'm actually around the limit there, but it's just it keeps hovering and topping itself off. You know, whatever. It's not in a bad zone, so if it wants to recycle its energy like that, let it. There it is. It did 12.4 again. And I'm still seeing those shots of 1.1 amps. That's usually when I see it come up. Then it goes down to 12.3, and then it gives it a shot of an amp. Yeah, the discredit. I don't know if it's just that or if, you know, they're focused, they have their own agenda. One's trying to sell a book, the other one's trying to sell a DVD, the other one's trying to sell a kit, and it's all, you know, narrow minded in that only, right? I gotta go back to the washroom. I'm sorry, I'm a little excited, and that's what it does. Ay, ay, ay. Oh, oh, Foofy did her pee. That's a good girl. Okay. That's a good girl. Boy, that's a good girl. No way, I know. You did all that. Yes. Okay, you want a yum yum? You want a yum yum? What you want? Yeah, go on. I know. Okay, here you go. That's a good foofy. Oh, now I've got doggy slobber and I gotta wash my hands again. That's a good foofy. Ooh. Okay, what do we have? 12.3. 12.4 again. So this is good because for people who say, oh, we don't have any proof, you don't have long videos, I'll say, look, I did one and I stayed up all night for you folks to show you what this thing can do. So, with a little bit of dedication and, proper setup, this could really work. And again, it just makes sense to charge separate batteries in the loop to take advantage of these gains here because they're pretty good. Uh, 12.3. I'll probably come back to 12.4 like it's been doing all night. Oh, yeah, there it is. 0.9, 1.1 amp. It's going to top it back off. I think the reason it drops like that is the charger is dynamic, right? It thinks it's charging, so it drops it down a bit. Then it realizes, oops, and then the charger doesn't realize what's going on right now. It's not designed for this, so it's getting partially confused. 12.4. But it seems to have no problems. As soon as it detects a slight drop in the battery, it tops it off right away. And I mean, that's got to use energy, folks. I mean, 12.4. The last post on the forum, I'm not sure. I was on there earlier today. There were a few replies about people asking for motors and stuff like that. People are asking for things I haven't done yet. Try it and let me know. So yeah, we've been going on for over an hour now. Feels like two. I'm always afraid, right, when I'm live that something will go wrong. So I'm extra on my nerves, especially when I'm not sure myself what the outcome is going to be. Wow, seems I'll have to look at that. No one wants to listen. I guess you opened up a new post, or because I don't think it's a reply unless you just did it not long ago. I don't remember seeing that. I'll have to look. Da-da-da. So far, so good. Again, here. Still flickering up here too. This one seems to be pretty well accurate with what I'm getting here, just to make sure, I'm checking both readings here. Get in here. Check my temperature. Inverter 74.3. Capacitor 78. Capacitors are slowly heating up. Nothing drastic, but there's a noticeable difference. Something's happening, something's circulating. But the inverter is not, it's not the inverter doing the work, I can tell you that right now. The capacitors seem to be doing most of the work right now, from what I can tell. Even the temperature difference seems to indicate that. It's so interesting, though, how the charger tries to dynamically adjust with the state of the battery. $12.4. I'll go down to 12.3 and then it gives it a 1.1 amp burst and it goes back up to 12.4. But I see it on my meter here, it peaks even more than that. There it is, 12.4. We're getting dumps of 1.1 amps. Very interesting. It's like the charger won't let it. As soon as it detects a drop, so once I have my new SCRs, I might be able to scrap the charger and go with the cap dumps instead. I think the digital circuitry is screwing around with me here. The charger gets confused. Because it would be ideal, keep the maximum charge, even though it detects the battery going up. That's super interesting, though. And so far, it's doing everything it should in theory, right? So it's really good indication. No, I haven't tried the MOSFET cap dump. I've tried it with my switch though, with just an NPN transistor. As you can see here in the back, I could dump the with timing. So I've been experimenting with that crudely. I think you can get the transistor to shut off faster if you reverse bias it. It is what time? 2:18 a.m. Oh, don't know how long I'm gonna keep this up here. And again, I could go on and on for 12 hours and someone's still gonna find critic to the demonstration, right? I guess you can't please all. But it's been doing the same thing right from the start here. It's when I hear the batteries, you know, it intermittently starts to boil. 'I'm just looking for low peaks, you know, even in the 12.2 is nothing. At 12.2 under a load, I'm done, no matter what. 12.3, I'll probably flash at 12.4. There it goes, 1 amp. So I'm probably going to see 12.4 there. They'll give burst as low as 0.4 amps, and then up 0.9, up 1.1. And then 12.4. There it went again. Up 1 amp. See, that's what I notice. When there's a high current burst, voltage goes back up. Which should be the opposite, right? Because if it would be directly coupled to the battery, a high current burst would mean, you know, a direct drop in the battery. But here, a current burst gives an actual. Well, that's good that the active power is completely decoupled from the reactive power. That's what we want. Yeah, I'm just using artificial ground for now. 12.4. It was giving nice high current bursts and by the way, I'm not like specifically taking it from the ether. That's for other projects. That does work, but what I'm doing here is taking the LC resonance and tapping off the reactive VAR power, which is much, much more than the input. So yeah, grounding will obviously work. It helps in all LC circuits for containing the interference and for stability and all that stuff. But for an LC circuit to oscillate and resonate, ground is not actually needed. But of course, in this stuff here, people have experimented with, using real grounds in different points and creating ground loops and things like that. And at varying degrees, that can enhance or go the other way around, harm you. So if you're lucky, that'll help. It all depends exactly what you're doing and what design. If you're doing like more the Bedini stuff and even the Don Smith stuff, then the two ground points could offer a potential difference. But for exploring VAR, it's not as crucial. It's more the for tuning purposes, like what I do sometimes, and I'll use just reflectors to help what I've said before, tuning the ground. So all good, all good. And I wish I had the stuff I wanted, the lab and everything, and all. That'd be so nice to build it properly. But this is a very good live demonstration, and every minute is as new to me as it is to whoever's watching. I just got intrigued, when I heard the battery boiling. So yeah, we're still doing very good. No drop. It just wants to peak up all the time. Even it dropped to 12.2 and then back up to 12.3. No, no. It goes down to 12.3, and as soon as it notices, the charger gives it a 1.1 amp, and then poof, it goes back up to 12.4. Mm. Yeah, the Kepagen, I did that years ago, like 4 years ago. At my old place, I have a demonstration of that, working through two ground loops. I had 100 feet of difference between the two ground, and I had two antennas, and I had a spark gap going through a tube rectifier, cold cathode reaction, giving me X-rays and everything, all from the ambient. no power source. I mean, apart from the capacitors charging from the ambient. I have a video of that. It was putting out the blue from the X-rays the tube generated during the rectification, all through the kappa gen. That was really interesting. But again, not everyone has the dynamics of messing around with ground loops and antennas and the land and, you know, but it is interesting for sure. But I've always been on the hunt for, practical, something practical, somewhat portable, that works everywhere, anytime, that you don't need a special PhD in Tom Bearden to keep maintaining. So that's been kind of like my goal, my quest, to try and find all these systems and find a common ground and then simplify it all. Yeah, a lot of people are saying that too. What if you're in a high rise or something? You don't have the luxury of finding two long separated real earth grounds. You got your building could be one, and that's usually tied to the mains, so you can't even use the mains as a second, and it's usually pretty polluted because it's everyone's noise. And yeah, I mean, nice if you've got a camp in the bush, but not everyone lives under those dynamics. So again, I've always been, trying to find a common ground and all of these devices, and they simplified. It'll just kind of work idea. Down the line, I would like to essentially use my power cells as the source because they can self-re-gauge and then have that as the trigger and charge a bunch of batteries through the LC stage. That's my ultimate goal. But of course, this off branches to so many different varieties and variants and motors and mechanics. And oh my goodness. So here we are. It's not going down at all. If anything, it's peaks up. I've got my other meter here too, and it's not going down. And all this time is work. And we're wasting a lot of it. This could be spinning a motor or something. But just for my own testing and prototyping, that this really does at least answer a question. Well, whatever's going on here, my inverter, which is supposed to be the input trigger, is like ice cold. It's like a couple degrees over room temperature. The only thing that's heating up a little bit is the capacitors here, which tells me the work is being all done in the capacitors sitting at 76 and the inverter is at 74. So I'm getting amps 1.1 bursts. It's keeping the voltage topped and giving the peaks here and there. One amp again. 12.3, there you go, 12.4. That's almost hilarious. It's like the charger doesn't know what to do. Oh, I'll charge. Oh, wait, you're charging up. I'm gonna ease off. Oh, you're dead. Okay, well, I'm gonna give you a big burst. Oh no, that's not too much. Okay, now I'm only gonna give you point. Yeah, I gotta like bypass this. Uh, Cap dump and SCRs. That's the next thing. But this is great. Needless to say, this is very great. This is simple. 1.1 amp there. My goodness, it's like giving me more bursts as we go along here. That's cool. 12.4 still. Oh, what time is it? 2:30. Oh my God. Tell me again who had this idea of trying this at 12 o'clock. Uh, well, we'll go as long as we can. I mean, I will refer everyone to this video next time someone tells me you only make 2-minute videos. We can't see what's really going on. We need to look at that VI curve while you're looking at it. Draw a straight line with intermittent positive peaks. That's been my VI curve all night. Quite an interesting curve, isn't it? That'll get the trolls talking. Last schematic you posted, I'll have to do that for sure. Just I'm too tired tonight to start getting all technical here. I'm having a hard time reading the readings out loud. And I always have to go to the washroom because I'm nervous. Because it's that clicking in my battery that's got me a bit on edge. It shouldn't happen, but it's not like I want a hydrogen poof, right? Because that 1.1 amp shouldn't be enough to do anything bad to the battery. But what's unusual is the input and the output happening at the same time here. No, it's running the battery out of typical range here. When you do things out of normal range, sometimes anomalies happen that you are not expecting. So I'm a little bit nervous about that. But it's good, nothing bad. No weird smells or anything. Acid's got the worst smell. Ugh, sulfur, right? Yeah, this is super, super, super. Yeah, a straight VI curve of 12.3 with intermittent up spikes. And over time, it's not dropping. Starting to run out of things to say and getting a little tired here. But all into it this far, I might as well keep her going. $12.4. I sound like I'm not even excited announcing it anymore. This feels like the Energizer Bunny commercial. It just keeps going and going and going. I'm just missing the drum. Maybe if I start playing Katrina and the Waves, I'll be more energetic for the night. 12.4, 1.1. There it is. Ugh. Yeah, I'm trying to keep up the good work and keep up my head so it doesn't pass out at the same time here. This is like way over my bedtime. I'm an old man. Now, with that said, I gotta go to the washroom. I'm nervous. I'll be right back. Oh, you don't want to go to bed, Foofy? What are we getting here now? $12.3, 12.4, of course. Of course. Let's check out my temperature. Inverter 74.3. Capacitor 76. What exactly am I trying to test? My Poofy, get out of there! Trying to test my LC circuit, the reactive circuit at resonance, and the power recycling. And I should have two batteries, but I only have one, so I'm self-looping it and eating up most of my gains. But even there, at 1.1 amps, I seem to be holding it pretty good, and even intermittent upper peaks. That's what I've been looking at, basically the VI curve. as I'm going along. I was expecting efficiency, and I was going to call it quits once I get about 12.2 volts for the evening and just assimilate the information based on the efficiency. But it's been going on ever since I started it, and the voltage hasn't gone up. If anything, it peaks up once in a while. So I'm just looking at that. I was going to record it, but my phone was dead. So the only option I had was to go live so I could keep a archive of the experiment. So that's why I'm in the middle of the night and looks kind of bad out here. But this was a completely on the spot. I really didn't think it was going to work just like this with all the parts I had. I built around with what I had instead of what I should build, but it still worked. Even if I didn't have the exact values I needed, I fine-tuned around what I had, and it seems to be working pretty fair. I'm getting over 14 watts back at 12 volts, and I'm putting out 40 mA at 12 volts. But that's just to show you how much I lose in inefficiencies trying to loop it back in the battery if it's just keeping it and just a little up. So it just makes more sense. It supports what I've been saying. You want to keep your run battery completely separate and have your charging batteries part of the loop. But I don't have all the 5 batteries to do that right now. So I was just screwing around, seeing just for basically shits and giggles how long the battery was going to self-loop in the reactive state. And it's doing pretty good. Even if I don't have the exact values, it seems to be topping it off and maintaining it pretty well. I'm actually surprised because I thought that after half an hour or so, my voltage would start slowly decreasing. But it's not. It's increased a little bit. And I was going to stop the recording once I got to about 12.2, but if this keeps up, I might just call it quits when I'm too tired to stay up. This movie will be saved, so it'll still be very long. It proves the point. Just because people have been saying, in other videos, oh, it just goes on for 5 minutes. It just goes on for 10 minutes. The VI curve does that. They were accusing me of exploiting the VI curve under a load where it needs to stabilize after a few minutes, and then you notice the drop. Well, I'm recording live so long that no one, or if anyone ever says that, I can point to this video, and if they got over an hour to watch it, there you go. But I would love to build this the way I have in the circuit diagram. This is essentially the same thing, but a very scaled down version, not as optimized. I think it's just my charger acting up because I'm using the charger right now, so it detects when it's charging, and then I've noticed when it gets to like 12.5, the charger sends like 0.3 amps. Then when it goes back down to like 12.3, it gives a 1.1 amp charge, and it peaks back up. But like I said, it's hard limited with the X factors. So even if I try to load, I could short out the AC side of here, and it's not going to take more than that 40 mA because it can't. It's limited by the X factor. So that's what I'm trying to get at, 40 mA, and I've measured it not only in math but with my meter right on the inverter. It's taking 40 mA, and the charger is putting out 1.1 amp at 12 volts. So how do you argue with that? It doesn't take a rocket scientist to say. That's why I don't like getting too much in the circuit and the reactive and then trying to find, if it's pulse DC or a real AC, true RMS. People argue with your values when you start getting into that. So I try and keep it very, very simple. I've got the 12-volt battery. The first thing that's connected is the inverter. Everything else, and right now it doesn't matter. What matters is what comes back through my charger back in the battery at 1.1 amp at relatively the same voltages. So it's a lot easier to figure out, what your in and out is versus trying to figure out, okay, well, the inverter is putting out 110 volts. So with the reactance, I'm dropping to whatever watts at 110 volts. Then I've got to convert that to VARs and then find out someone's going to pick at the math, So it's a lot easier to just, input, output, DC. That's it. If you want to argue what's going on internally in DLC circuits, that's fine. But what matters at the end is what's coming back in the battery and what's leaving the battery. Yeah, well, if I plug obviously, if I plug the charger in the mains, it'll just, the battery will start, it'll eventually get to 13 and 14, right? Because right now it's being it's the input at the same time as the output. The only thing that's saving the battery is at random, because it's an inverter, it's chopping up the input, So, and its capacitor is charging in the inverter. So what I'm getting at is for a moment in the cycle, the battery is able to receive. If this were like a straight, like a regular, let's say a 50-watt DC load, this would probably not be possible because the battery is not good at being in a state of receive at the same time. You have to sequence it just right. So being out of phase with reactive power is a good way to start. Okay, good night, everyone who's deciding to call it quits. I'm probably going to do that very soon there, because the point I think is proven. 40 mA, and I mean, right now the values are not in my mind. It's so. But I have it all written down, and the math is there, and the math X says exactly that, and I'm measuring the same thing that the math has given me. So, I'm pretty confident of that. Aside that my inverter's fan isn't running and it's running, everything is indicating to me that what I'm reading, what I'm calculating, what I'm observing is all right. So with that said, you know what, folks, I think I'm going to go to bed. It's very late, and I'm gonna shut this down there. It hasn't dropped at all. I've been doing this for about 2.5 hours now. So no one can argue and tell me I'm exploiting the VI curve. So this will do a good reference video if someone ever asks. So with that said, folks, again, thank you for watching, and I'm sorry if this video got a little boring. It's just for me from my archives. Because, like I said, my battery ran out for my cell phone and I had to record right away. Because, it's one of those on the spot things that happen. Sometimes that's how I experiment. I just, randomly start something, and next thing you know, I get so carried away, I don't even realize what time it is no more. So, with that said, folks, have yourselves all a very great evening. It's like almost 3 o'clock here. I gotta get to bed. And I hope you enjoyed this demonstration of VAR power. Thank you very much.